Back on our C-Reactive Chemistry. Today we're going to continue to describe our matter. Now we've been talking about how we observe matter. Physical, chemical, intensive, extensive, qualitative, quantitative, pure substance mixture. Now we can start to quantify the matter that we're actually looking at and observing in the lab, and we do that using our units. And we know units are incredibly powerful for us, that they tell us not only what substance was measured, what physical characteristic was measured, but also what tool is used to measure it. If, for example, you were measuring grams, you measured the mass, the number of particles, amount of particles in a substance, and you used a balance to do that. Now we have a variety of other units that we can use to describe different substances in the lab. Now the Internationalis system, Internationalis de Unities, or the System International units used all over the world, have come up with a set number that we as chemists use that match the chemists in Sweden and Germany and Switzerland. This allows us to compare our results and share labs worldwide. So for length, we're going to use meters, meters being the standard metric unit for length. For mass, we use kilogram because grams about the size of a paperclip, pretty light. And so we'd have to report really big numbers. So we usually will report kilograms. For time, we use seconds. Temperature gets this little K, which stands for Kelvin. Not Calvin, Kelvin, Kelvin. Lord Kelvin worked a lot with our temperature. And what's nice about temperature is Kelvin starts at zero, absolute zero. You can never go negative Kelvin. We also have the amount of a substance. If we were looking at the amount of particles in that substance when it relates to reactions, we often will use this funny little thing called a mole. Now that's going to come back here in the future, but mole is going to be very, very important to us as we continue to look through our chemistry. So these are the units that we use: meters, kilograms, seconds, Kelvin, and mole. These are the units we're going to use in this class to start looking at the world around us and starting to measure it. Now, sometimes we'll change some prefixes. Now, meters, that's a base unit, just got the one letter. Kilograms actually has a prefix kilo. Kilo being larger than just a gram. Grams are small. And so these prefixes will change. If you ever just have one letter, if it was just grams, that's be what we'd call a base unit. Kilograms refers to 1,000 grams. There are 1,000 grams in 1 kilo. But let's look at a list. Maybe that'll help clear up all these different units that we have. For our metric prefixes, there are a huge number of these metric prefixes that you may have heard before. For example, a megabyte or a terabyte, or if we're going even larger, or if we were to go smaller, we've got micrometer or nanometer if we're going on the way small side. Now, the ones we're normally going to use are the ones listed here. Mega gets the capital M, so a megameter would be a big M, little m. A kilometer or kilometer would be a km. A hectometer is an hm. Decameter is a dam. A decimeter is a dm. A centimeter is a cm. A millimeter is an mm. And a micrometer is this kind of funny. It's called mu. This little squiggly um. Now, right here in the middle is where we put our base unit. And so what we've got here is actually the power of base units in one of these prefixes. So if meter was right here in the middle, just right smack dab in the middle, if we had 1 decameter, there would be 10 to the first meters. Well, 10 to the first power is 10. 1 decameter is equal to 10 meters. Hectometer. 1 hectometer would be equal to 10 to the second meter. Well, 10 times 10 is 100. So 1 hectometer is equal to 100 meters. Same goes for kilo. 1 kilometer is 10 to the third, which is 10 times 10, which is 100 times 10 more, which is 1,000 meters. Now, really, in chemistry, we're going to work with kind of the core 6, that kilo to milli, with the base unit kind of right there in the middle. Now, going on the small side, we got deci, a decimeter, a little dm. 1 decimeter is equal to 10 to the negative first, which is a tenth of a meter. Centi is 10 to the negative 2 meters, which would be 100th of a meter. Milli would be a thousandth. That's kind of hard to say. A thousandth of a meter. Now, mega and micro, it's good to know they're out there. We're not going to be using those in this class, but even now, there's still kind of a lot to keep track of and a lot to remember. And these powers are nice, but there's an easier way when we start looking at our metric conversions. So repeat after me. King Henry died by drinking chocolate milk. 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 Yeah, so King, kilo, Henry, hecto, died, deca, by base, there's your base, like meter or liter or seconds, drinking, deci, chocolate, centi, milk, milli. Now, the way we've got this written is from largest units down to our smallest units. And if we think about it like hopscotch, I love the metric system. It's all powers of 10. Every time you change from, say, base to deci, if it was hopscotch here and we're hopping from base to deci, we're changing by a power of 10. If we're going from base to deca, we're changing by a power of 10. So if we just use this handy little conversion factor, this little mnemonic device, this name system, we can actually skip our decimal around to change the units from a really big unit like kilometer to a really little unit like millimeter. Now it makes sense. Say you had 1 kilometer. You're starting way over here at 1 kilometer. You have 1 kilo of something. So 1 kilometer, sure, why not? And we want to know how many millimeters that is. Now the first M here is the milli, the second M is meters. Now we're starting here at kilo, and if you had to put a decimal in, where would you put it? Hopefully you said after the 1. 1 with a decimal would go, oops, sorry, right after the 1. Now it's just like hopscotch. We're going to move 1, 2, 3, 4, 5, 6 hops from kilo to milli. We're skipping 6 hops. We're going to do the exact same thing with our decimal. We're going to move our decimal 1, 2, 3, 4, 5, 6 decimals in the same direction our hopscotch happened. So we went 1, 2, 3, 4, 5, 6 hops to the right, and so we're going to move our decimal over 1, 2, 3, 4, 5, 6 spots to the right. Now we got to put something in its place. Natural thing to put in would be a 0. 1, 2, 3, 4, 5, 6 hops to the right. Now, if you want to put the commas in, if it makes you feel better, feel free. So what you just told me is if you had 1 kilometer, one really big unit, kilometer, we talk about 5Ks all the time if we're running far distances, is made up of 1 million millimeters. It makes sense that there's going to be a lot of them in 1 really big kilometer. So you can use this kind of metric system, King Henry died by drinking chocolate milk, to change all sorts of units within the metric prefix. It's so nice. We don't have to worry about 12 inches in a foot, 5,280 feet in a mile, these crazy random English units that were decided by some English king somewhere along the line. 10. All you gotta remember is 10. If you move one way, it's add a 0. If you move the other, you move the decimal to make the number smaller. Let's try another one. So for example, if we were going to go from centi to meter. So here we're starting at centi, which is over on the right, little units over on the right. And we're going to base. We're going to hop 1, 2, 1, 2 hops to the left. We're going to do the same thing with our decimal. So if you're to put the decimal in, it's going to be after the 1. So we put our decimal in, it's after the 1. We're going to hop it 1, 2 hops to the left. Well, the first hop makes it 0.1. Our second hop moves over and makes it 0.01. So 1 centimeter is equal to 0.01 meters, or 100th of a meter. Now, keep in mind, these are describing the same distance. 1 centimeter, about this big, is the same as 1/100th of a meter. It's the same physical substance. All we've done is change the unit that we're using to describe it. Okay? Metric conversions, there's a practice piece for you guys if you want to finish up practicing these and then transition to the Blackboard site to continue working on some of these metric conversions.